Thank you very much, Beck. It was amazing to be part of the Climate Robotics Summit organization and be part of the Climate Robotic Network in general. Good afternoon, good morning, and good evening, everybody. So depending on where are you connecting from. I'm the moderator, so that means that this afternoon in Italy, I will just lead the discussion between five very interesting researcher and professor spanning the whole domain of climate robotics. So I would like first to do a walk around the panel so that we have all of them here. Professor Louise Manning.
Hi, my name is Louise Manning. I'm Professor of Sustainable Agri-Food Systems at the University of Lincoln. So it's great to be here today.
Thank you, Louise, for participating. Dr. Salman. I think that I see Dr. Salman here, but maybe there is a problem with the microphone.
Yes.
Yeah, it is.
Now do you hear me?
Yes, we can.
Okay. Yeah, sorry, I had some problem. Oh, pleasure, everyone. Shall I introduce myself?
Yes, please, just very briefly, and then I will ask you some question. My role is mostly to timekeeping. So basically ask you some question, check that we are going in time, and then collect the question from the audience. But you are the people on stage.
Okay, sure. So hello, everyone. My name is Salman. I'm joining from Zurich. I'm running a spin-off of ETH. We are building a robot to help humans in greenhouses. We are basically automating part of the tasks, which is harvesting and deleafing of tomatoes at the moment. So this is the brief introduction.
Amazing, Salman. I'm just checking that everyone is here. Aurel?
Yeah, hello. I'm Aurel. I'm the co-founder of Caterra. We built robots that reduce the amount of hand weeding required in organic vegetable farming.
Thank you. And now Suma.
Thank you, Marcello. Hey, everyone. My name is Suma Reddy, founder and CEO of Gather Agriculture. So we are building simplified robotic tools for farms and farm workers. First product is an autonomous small-scale transportation robot for table grape farms, small farms, and universities.
Fantastic. And last but not least, Katie.
Hi, I'm Katie Bradford. I am a co-founder and CEO of Rotate 8. We're designing low-cost, modular, and repairable tools for farms. So this includes our Precision Farming Rover, which is a general-purpose mobile robotics platform for hosting farming implements.
Thank you very much, all the panelists. What I will do next is introduce myself, because I realized that I did not do that. I'm Marcello Calisti. I'm associate professor at Scuola Superiore Sant'Anna. I worked in the past on crazy bio-inspired robots that could inspect and monitor the seabed in a more gentle way than traditional robots do. And then I spent a few years in Lincoln working on agricultural and aquacultural robotics. So perfect for this session. That's where I met Louise in person, and we worked together in a very interesting topic. I'm excited about the panel today because it's collecting not only roboticists under the robotics point of view, but also a little bit under the user point of view. So in the sense that people that are going to use the robots for real. So I will go again around the panel, asking three basic questions. So why is the challenge that the climate problem that you are tackling important? What are you doing to tackle it? And how are you doing that? And starting with Louise, if it's fine with you.
That's fine with me. So I am not only a professor, I'm also a farmer as well. So my daughter's a farmer and my husband are involved with the farming business. The real challenge with climate change is farmers are experiencing differences right now. And they are seeing whether that's weather patterns, long-term issues with their soils, and also a lack of labour. And so robotics offers one solution among many to alleviate some of those issues, either by giving farmers more real-time information so they can take effective action on their farms, or substituting or replacing some of the activities that were previously done by humans. And that's where I really get involved, because I'm interested in collaborative intelligence. I'm interested in where the robot meets the human. How does that affect aspects such as personal safety, food safety, and environmental impact? And also I'm interested in that human in the loop. So I'm not a roboticist, but I am interested in how do we get the best of both worlds? How do we develop solutions that are of benefit both to the users, but also provide viable businesses for roboticists and spin-out companies? So that's me.
That's amazing, Louise. And I think that that's very important, because I'm a techie geek, okay? So I love my tools, and I love bringing the tools into the world. But sometimes robotics, especially when we bring it to the field in agriculture, underwater, in aquaculture, is more than just an element. It's interacting, and it's a complex ecosystem. So thank you for your brief introduction again, Louise. And Salman, why are you, is the problem that you are tackling essential? What are you doing and how?
So the way we relate to climate is basically under the umbrella of greenhouses. Farmers are maybe one of the big victims of this climate change. They go indoors because they're protected. So plants actually enjoy the climate of a greenhouse, but people don't. People just suffer. It's so humid and hot. And, when it comes to manipulating the plants with fingers and eyes and really intelligence of a human, there is no robot yet. There is no automation system, but the rest of it is really automated. Whatever you can imagine, there are machines that treat the plant. There are UV treatments. There are like automatic logistics. Every weather control is automatic there, but human is still the winner of manipulation, and that's how floating robotics is coming into the scene, because we think that a big part of the job is with this skill of human, and humans don't like it. Everywhere we go, there is a labor problem, and we see always like new faces. When we see someone, in 2 months he goes, another one comes, because they don't like it. They just find alternative jobs and go. So this is how we are trying to automate a difficult part of the job.
Thank you very much. Again, this pivoting around automation, making the work accessible, and tackling this challenge is not a simple technical challenge, is not a simple social challenge, and the answers are complex also on the skills that needs to be taken into consideration, either to deliver or to use the robot. And Aurel, while your challenge is important, what are you doing? How are you doing it?
Yeah, so if you're a farmer, vegetables, herbs, fruits, whatever, you always have to fight with weeds. So we're outside, we're not in a greenhouse. And it's one of the main costs in production. So if you use herbicides, you don't have a big weed problem, but if you're an organic farmer, you have 90% mechanized with tractors, but the last 10% of the weeds, which you have to pick by hand, are really expensive. So for example, in Switzerland, it's 20 to 50% of the production price of organic carrots. And this is done by humans. And it's very hard as a farmer. You become a manager because suddenly you have a team of 50 hand weeders or 100 hand weeders. And often you don't find people to do this job because it's one of the hardest that you can do in the field. And we are automating this with an autonomous robot, which only eliminates the weeds which are picked by hand. So we're not an alternative to tractor-pulled solutions, but really just the manual labor. And our goal is to reduce the amount of herbicides used in agriculture.
Thank you very much, Aurel. It's nice. Yes, feel free to put link of your work in the chat so that all the audience can see if needed. Again, it's a very long process, several steps. So it's very nice that you tackle specific different areas, greenhouse, outside, one part of the chain, or the whole chain. And that leads me to Suma. Why the climate challenge that you're taking is important? What are you doing? How are you doing it?
Yeah, I'll probably repeat a lot of what people have said, but just to ground it, for us, we think about the problem in a couple different ways. One, macroeconomically, right? Challenges around workforce and labor. So 20% worker shortage, where we are first headquartered, which is California, declining 7% a year. Obviously not helped by the current administration's threats of constant deportation for workers. What we're also seeing is the average age has increased from the being in your 20s to now 40 years old. And that has also linked to over $8 billion in terms of injuries due to rising temperatures. Again, California gets pretty hot in the Central Valley, very, very hot. The third part of the challenge we're seeing is crop left on field. I would love to see more studies on this. But at least a few academic studies have shown that there's anywhere from 30 to 60% harvestable crop left on field. In California, if you just take 30%, that would be $18 billion of the total cash receipts. And then directly for the farmer, the farm worker, what we're seeing is outdated tools. I mean, this is something this panel knows well, but a wheelbarrow invented 2,000 years ago in China is pretty much the same tool that we use now. And we're using that to haul crops across fields. So those are the main challenges. I will hit another one as well in terms of adoption. When we talk to growers, they had mentioned, right, the cost and complexity. They were like, we want to adopt these tools, right? But oftentimes there's been an overpromise, under-deliver of what the tools can do. And then when we do adopt the tools, they're so expensive that the ROIs don't make sense. And then on top of that, the complexity, whether it's the required infrastructure, for example, if GPS is required, or how heavy the tool is, the amount of training, right, for an autonomous robot, things like that. So that's how at least we think about the problem and approaching a solution.
Thank you very much, Suma. I see that there is already a question in general. I will use it after Kathy's talk to go around the table. So, Kathy, why the challenge that you are tackling is important? How are you doing that, and what are you doing?
Yeah, so similar things to the other people doing agricultural robotics, but specifically focusing on polyculture growers. So right now it's really hard for small growers growing a variety of crops, whether that's for farmers markets, CSAs, things like that, but also grocery stores, to compete with these monoculture growers. So if you have these like giant farms that have huge acreage that are growing one crop, and they have all these specialized tools, and there's a lot of money to be dumped into specialized things for things. They're also just dumping pesticides, lots of fertilizer, excessive water use. So kind of take a monocrop monolith, and also kind of negatives for the environment. It's really hard for small growers to come onto the scene, to compete with them, and to grow healthy, organic, sustainable food without tons of fertilizer, pesticides, without these like specialized tools for single crops to compete with those growers. So we're trying to make it possible to grow healthy, local, sustainable food without all these specialized, expensive tools, by making general purpose tools that are more suited for polyculture, biodiverse environments. Yeah.
Well, that's great, amazing, and it goes very well with the question that has been asked. And I will go around with the question coming from the audience. The idea is that you all spoke about the impact, economic impact of wasting, of letting the food on the field, of not weeding in the right way, and so on and so forth. So it seems that a lot of those part is related to money, but to get the tool to improve this, there is a lot of money involved. So how can small growers benefit from robotics and from your solution? So what is your point of view, starting from Louise, which has a great experience in acceptability, in interacting between roboticists and farmers, and then moving to your specific solutions?
Thank you. So a lot of our work, which I'm not going to go into great detail today, so if anyone's interested, please get in touch, is around the barriers and enablers to farmer adoption of technology on farm, and specifically robotics. But I think what's important to say first is there are many, many different kinds of farms, and we've talked about monocultures, we've talked about large-scale farms, but there are equally across the world very many micro farms, or indeed family farms that are smaller scale. So if you were to look at the value proposition of robotics and the return on investment, it will vary by business, and depending on whether they're a monoculture or a mixed farm, it will vary as well in the individual countries, what subsidies farmers have. So in England, for example, we have seen a huge change in the subsidies that farmers were receiving. So that immediately changes the return on capital calculation. So I would say the future, and one of the exciting futures for startup businesses in rural areas, is robots as a service. It's highly unlikely due to the cost, and also the upscaling that will be done, and the new, I'm not using the right robotic terms, but the technology development, it would be unlikely for me as a farmer to invest in a first generation tool when 18 months later the second generation tool has a different value proposition. So I would argue that robots as a service and is likely to be one of the ways in which you develop scale.
Amazing, Louise. Robotic as a service, that's a very nice point of view rather than using a tool. And that also links very well to Suma comment that sometimes we over-promise. Let's be frank. So our robot will do everything. Could I just say one more thing? Right?
I'll just say one more thing, because I think it's really important. If you look at a combine harvester, in some parts of the US, the farmer may use that combine harvester for several weeks because they've got very big farms. If you look in England, on my farm, we would have a combine harvester for 2 to 3 days on our farm. Why would you buy one? We have a contractor who comes to our farm. So I'm just extending that to thinking about robotics.
Great. So makes no sense to have a huge investment, and that can help small farmers. Salman, what's your point of view on that? How can we help small farmers as well, and not only big companies?
So this is a bit challenging for startups because when scales are small, I mean, we were starting small. We were, before harvesting tomatoes, we were harvesting grapes, and we were like in small vineyards around Lausanne and, you know, the Swiss French part. As we showed the farmers, like these things can work, when we ran into calculations and we calculated like how the economics work, it was barely profitable. And then the farmers said, okay, what else? What else can you do? Like, then the robot started like developing very, very different skills so that our startup can use the time like efficiently. You know, when the robot is there, it shouldn't be just idle, it should work. So this was, I wouldn't call it a trap, but it was getting more and more difficult because it was kind of a distraction from one topic to another and then to another. So I would say if one day maybe robotics reaches a point where robots can do multiple things, then you could make the economics work. You can like rent a robot as a farm assistant, and today tell him to do something, tomorrow tell him to do another. So at the moment, we did this pivot to greenhouses because things work at a scale. Even with a small Swiss farm, we can make a couple of robots work like multiple months per year, 24/7. But it really depends like on the task, on the part you're automating. If it is a small, then you fall into logistics of moving the robot from farm to farm, or like to the complexity of developing multiple things.
Thank you, Salman. Aurel, what do you think about that? Anything else to comment on help for small farmers?
So in our case, we have once the competition from tractor pulled machines, which are very large and not efficient for small farmers. And of course, then the human as a competition, which is very flexible but slow. And we are something in the middle. And yes, robot as a service is an option, but more we sell the robot to farmers who then offer the service to other farmers. Or we sell it to large farms, or 5 small farmers share one machine. So in our case, all the business models make sense and each farmer wants something different.
Mm-hmm. Okay, I see. Thank you very much for this point of view. It's another approach, of course. It depends on the acceptability, of course, also of and initial capital, I guess. Suma, what's your point of view on this?
Yeah, I think for us, the first step has been really driving down the initial bill of material cost and cost of goods sold from what we see traditionally. So if a price point traditionally has been 21,000, right, can we drive that price point down to 6,000? And so for us, it's been building an iPod, right, rather than building an iPhone. So do one thing really well, and then hopefully build complexity over time, right, as farmers get used to robotics in use cases. So that's one. On the business model side, there's so many fun ways to do this, but it does feel like a giant experiment. So whether it's direct sales, leasing the equipment, right, we've talked about robotics as a service. The other thing that feels interesting, we haven't tested this, is selling units and then kind of, like when you get a new iPhone, right, you can kind of return it. And then is it possible to sell those to different farms, right, at a cheaper price, things like that. So you can kind of upgrade your equipment. But there's a lot for us to learn. Like we honestly, this summer, we'll really be testing some of these models for the first time.
Amazing, thank you. It's very nice. So let's say start from something specific, then large maybe can help acceptability and intake for small farmers. Katie, I think that you were eating as the first person this problem, mentioning that different crops at the same time is something that small farmers do. What is your secret? How are you doing that?
Yeah, absolutely. So similar to Suma, we're aiming for a really low cost of the machine. So our precision farming rover, we're selling for $10,000 on average per year in California. A farmer spends around $36,000 per laborer. So it's a pretty quick ROI calculation for our customers to consider if these robots are working alongside people, making them more efficient, requiring less labor overall. The ROI can be a matter of months and definitely under a year. So it makes a lot of sense financially. And again, it is a general purpose tool. So instead of having a tool that only does one part of the process, like Louise was saying, if this tool only did combine harvesting, it might not make sense financially for those to replace those 2 or 3 days of work. But given that the implements can be swapped out on the machine, so we basically have a 3-point hitch. You can attach different tools for soil prep, for cultivation, for seeding, for harvest aid. This tool can kind of adapt through your process, like as you're going through the growing cycle. You can use this for different things. And then in terms of the use case for selling, we are selling direct to customers. One thing we've talked with our customers about a lot is the right to repair. A lot of farmers own equipment, such as tractors, that they can't fix themselves, and it becomes very costly, very difficult, very time-consuming to get repairs on their machines. So one thing we're really focusing on is being able to fix the machines yourself. So once you buy the equipment, you own the equipment, you can modify the equipment to your needs, and then you can also fix the equipment yourself in-house, which will save farmers time and money and have them have more ownership over their equipment.
Katie, amazing. Thank you very much. Right to repair. It's a very nice, very nice idea and very nice thing. And also it gives me the spin for the next question, taking a little bit from what people wrote in the chat and adding my own curiosity, let's say, and then going the other way around this time, Louise. Sorry, I saw that you unmuted yourself already, but just to give it a twist, and I will put Katy again in the spot, and then when I reach you, I will frame the question a little bit differently. But my point is, Katy, people are asking, vision, mobility, but there are so many challenges in robotics. I bring robot myself into the field, and every time that I saw a different polytunnel or an orchard, which is particularly difficult to navigate, I say to myself, I will never work in this environment. So I have two questions for you. What is the most difficult technical challenge, in your opinion, that agri-robotics is still facing, and what is the most social challenge when you interact with the farmer? The most complex social challenge, let's say.
Yeah, bring that back to the adoption a little bit. One thing we're focusing on with our rover is that even if it is not autonomous, even if it's not, using AI and navigation and these things, it's actually still very valuable to the farmers as a general purpose platform for hosting implements. And we have users using it just as an RC platform. So this not only increases adoption in terms of they get comfortable with the machine before they start adding in these autonomy features and these robotic features, but also it adds confidence back to the users. A lot of like other people were saying, there's these people over-promising, under-delivering, and then also sometimes the company just goes out of business, and then you have this expensive robot that you bought and it doesn't work anymore because no one's supporting it. This happened really recently with a greenhouse automation company, and farmers are just stuck with this machinery now that doesn't work. And so our promise is that even if God forbid we're not here in a couple of years, our machine will still be useful to you because you can use this manually, and it's still providing great ROI. In terms of technical challenges with farming robots, I would say the variety of farms, as Louise was saying, every farm is so different. They're different in terms of the crops that they are harvesting. They're different in terms of their terrain. Is your soil we have a gravelly soil, we have clay soil, we're going up inclines, we're dealing with muddy fields in the winter that oftentimes traditional heavy tractors are getting stuck in. So making a tool that can be used in all of these different terrains, and oftentimes we're finding that you can't make one tool, right, that exists for everything. So having that modularity in our platform, maybe you swap out to fatter tires to accommodate these muddy fields, or add weight on the lower part of the platform to get better traction going up steep inclines has been something we're exploring.
Thank you very much. The skill required to the farmer to repair, to maintain, to execute the robot are quite challenging. So again, Suma, in your point of view, the most complex challenge in interacting with the farmer, the most complex technical challenge that we still have.
Yeah, I think I'd love to talk about the industry generally rather than my own company or robot. I think in the past, what we've seen, right, venture capital is not investing in ag robotics. There have been no exits in the US of note. There have been no acquisitions. Last month, 2 companies who I really thought would do well, Advanced Farm and Tortuga, basically got acquired. They weren't great acquisitions. And so what we saw is the sexy robots, which are the robots that pick apples, that pick strawberries, right, haven't been able to hit the success metrics for farms and farm workers. And those are the sexiest use cases, at least in the US, right? Because apples and strawberries are the highest volume crops. And everyone just likes to talk about picking fruit. So I don't have a solution here, but I think, a lot of what we do is like, let's start, again, iPod, let's start small and build incrementally from there. But I am curious from this panel, right, what they think about, when I founded an indoor farming company, it used to be like the holy grail of indoor farming would be to grow a strawberry, right? And so I'm curious, is the holy grail of robotics in some ways in ag, right, actually building an apple picking robot, right, that, you know, is easy to use and cost effective? So I'm curious just from the rest of the panel how they're feeling, you know, about some of these deeply advanced systems that just have not been able to bear fruit. Sorry for the pun. Yeah.
It was perfect. What is the lowest hanging fruit to make a picking a company or agriculture company successful? And I share your pain in this sense. Now, say we are doing great. The market seems that everyone needs to eat, and company fails. Why is that, Aurel? This very simple question for you.
Well, I think the main problem is you don't have much time because you have to show progress and success. And how do you show that? By saving money. So the farmer has to save money with a highly complex product. And similar to milking robots, it just takes a long time until the technology is ripe for the market and for the customers. And they have to get used to this technology. And it just takes a lot of time. And I mean, we are now in our 3rd or 4th season, I'm not even sure, working with the customers, making the perfect niche so that they really save money and they get used to our machine. Yeah, I hope this answers the question. And maybe to the other question, what is the most difficult thing on a technical level is really the robustness. So our robot is in the field 7,000 hours a year, which is much more than the humans and much, much more than the tractors. So it has to be much more robust, every part of it, mechanics, the electronics, the antennas. And this is like the biggest challenge for us in every weather, in the snow. Well, not if it's too much snow, but if it's a little snow, it still has to work. This is really our challenge.
Yeah, yes, great, Aurel. I mean, I love your robustness point of view. The research is not paying robustness, right? So pay novelties in the universities, but novelties conflicts with robustness because something that is very novel usually works a couple of times, then it has to be done again. So there is a real reflection on how you evaluate innovative solutions in university and how you bring it to the field. So yes, great, thank you very much. Salman, the question for you are increasing. So how to make why is the problem that the companies are failing? What is your most difficult challenging technical challenge? What do you think the skills that needs to interact with the farmers? Louise, you will have a lot of questions when we reach you.
I would maybe add to what Aurel said. So we are basically focusing on KPIs. I mean, all the time we are talking about KPIs. KPIs for us as a speed and precision, right? So often we look at our competitors. We see like this robotic company did this. What's the latest? You know, but to be honest, our main competitor is human, right? Human is amazing. And I mean, in our field, maybe for other robots is a bit different, but comparing to humans, robots are slow and we understand it very well. So our struggle is basically to make a table and show everyone that our robot can return the investment soon enough. I mean, maybe 2-3 years, something like this. But, you know, precision, or I would say success rate and speed are like two conflicting, you know, goals in robotics. You can make something very slow but precise, or the opposite. So this is a bit challenging. Speed is especially challenging, but maybe one point that we are now facing is basically the amount of work we can do. Like I would say the percentage of the crops we can pick, and what happens to the rest. This is always a question for farmers, how the calculation works. Also, the robustness of not the robot itself, that's of course important, but also robustness of the work. Like, are we really damaging something? What's the percentage? Or like, imagine, for example, in one row of a greenhouse, we damage 1% of the plants every time. So we are passing through the same row like 40 times per year. At the end of the year, we have damaged 40% of the plants. And 1% is already very low in robotics. Imagine when you repeat something, it just adds up and it can be damaging to the plants. So this is really like a challenging point for engineering. We have to really sit on the robots in the field days and nights, like observe exactly what it's doing and kind of debug it, kind of find the problems and try to solve them. This is taking time. This is so difficult to do.
Thank you very much, Salman. So we are getting to you, Louise, with all these questions, plus this complexity that Salman is giving. What is your point of view? And then we have 5 minutes to do a hot take from all of you, and we close the session.
Okay, so I think that one of the real challenges is that the industry that all these robotic solutions are being designed for is a very low margin industry, and whether it's productivity subsidies or price of food, the same person pays for the transition that we need to have for climate change. So many of these businesses are low margin, which makes investment difficult. Many of the crops we're trying to harvest, and if I talk about harvest specifically, are high-risk foods. So hygienic design of food contact parts becomes essential. Otherwise, retailers and food service will not approve their use through their farm assurance systems. Insurance. In the UK, we have a much greater right to roam through fields than you do in many other parts of the world and across Europe. So insurance becomes very important. The rights to data, we talked about rights to repair, the rights to data and the ethics associated with that. If we expand it to livestock and welfare, if we look at integration with human wearables, where we're looking at collaborative robots, or we're looking at greenhouse gas emissions, what happens to that data? And farmers are very concerned about that data being used for a whole range of purposes they didn't sign up for. One of the biggest ones that I can see is green versus red AI, and the amount of computer processing that's being undertaken by many of the technologies and its own impact either on water use. And one of the things that are being looked at in the UK right now is having to build reservoirs for data centers because of the water use, but also the greenhouse gas impact. And just to touch on people, many of the people that respond to our surveys, they're already farmers that work on their own all day. They say, if you automate more, we're going to be even more lonely. And you can't always have a chat with a robot. That was one of the responses. So there's a whole range. Well, that could be solved, of course. So there's a whole range of things that I think we need to address so that we can get better deployment of robots.
Louise, thank you very much. It's amazing. Robotics and agriculture and aquaculture, they are so intertwined with society, which is so complex to address the task alone. Interdisciplinarity may be the answer, but still, I fear that we raised more worries and bad points than questions and then the good answers, let's say. So we have 2 minutes left, starting again from Katie, maybe a positive hot take of what robotics is doing in agriculture and what can do in the future. Very quickly, because we have just 1 minute left. So just a single hot take that you have.
See, hot take. I guess coming back to a point that that Suma was making about kind of VC funding for agriculture robotics is that people these VCs often focus on like the sexy things, picking a strawberry, or indoor vertical farming was another one that has been getting a lot of funding. And then recently, you hear about things like Plenty, which raised $1 billion and then went out of business. So I think I'm kind of we're seeing a refocus in some of the VCs that I've talked to and in the industry in general on achievable the low hanging fruit of autonomy and getting those solutions really right and making them robust and successful for farmers before adding in these complex, these humanoids, these arms, these pickers, etc.
Thank you, Suma. Your hot take?
Yeah, I think to add on to that, I think we'll see the industry. So Katie and I think are really focused on specialty crops like fruits and vegetables, right? And the things that haven't, obviously, right, for robotics, right, haven't been as automated or mechanized. I'm curious to see when we start to see more mergers and acquisitions, even at a small scale. So companies that say, hey, we're sort of doing the same thing, but why don't we join forces and tackle things in California, in Malaysia, in Kenya, in India, right? And sort of, you know, I'm definitely not a, oh, we should go big kind of person, right, all the time. But I also think that the scale of this challenge is huge enough that some more collaboration and partnership could really advance the solutions.
Thank you. Aurel?
Yeah, maybe I think everything that can be done by a tractor should be done by a tractor, and optimizing this with an autonomous system is often not a good idea.
Okay,
Yeah,
wait,
unfortunately.
great. Yeah, no, nice. Salman?
So, so I think investors they should talk to farmers actually more often. That's what we are basically missing, because farmers desperately want us, and investors always look at the numbers. I mean, if they're a little bit more patient, we can reach the point that it makes it profitable.
And we have all to eat healthy foods. So yes, Louise, let's close it with your hot take.
Okay, so around 1/4 to 1/3 of food around the world is lost before harvest. Robots have a real opportunity to have less extractive practices, more regenerative practices, and address that food loss.
Amazing. Thank you very much. We are just 2 minutes late. The panel was super interesting, and that's why we ran a little bit later. We have also questions from audience, and maybe they can be directed directly to you. They shared the LinkedIn pages, so in case that there is still interest, please contact all our speakers. Let's do a big round of applause to all our amazing speakers, and thank you very much for participating in this session.
Thank you.
Thanks for organizing.
Thank you very much.
Thank you.
Thank you all. I think that was phenomenal. Taking lots of notes. I think we have our research pitch session, so that's to Burke.
Yeah. Nice to meet everyone. Lovely to meet everyone.
Thank you so much, Marcello. Next is research pitches. So we will take a moment to have our research pitch speakers in the panel session. And while that is happening, let me introduce the panel. So welcome again, everyone. This is the session for research pitches. I am Marcello from Robotics Engineering Department at Worcester Polytechnic Institute, WPI, which is located at Massachusetts, United States. So in this session, we prioritize to provide a presentation opportunity to as many researchers as possible. So our goal is to expand our mind map of climate robotics activities and where they are happening all around the world. We will have 8 researchers presenting their work. And to allow this, we have some fast-paced presentations. Each will take 2 minutes. We will not have questions during the session, but please post all your questions to the Q&A tab so that our panelists can answer the questions directly from there. And please also explicitly state who your question is directed to, so that it would be easy to track. We will also provide links to the profiles of our speakers so that you can learn more about their projects and also follow up with them afterwards. So with that, I will share my screen. And we can. Sorry, we are receiving some background noise. If it is possible to minimize it, it would be great. Thank you very much. And with this, Giacomo, please take it away. And please unmute yourself. Thank you very much.
Yeah, thank you, Berk. I'm afraid the background noise comes from me, actually, but it's great to meet you all. I come from the Marine Science Institute of CSIC in Barcelona, Spain, and my presentation is about my research job, which is happening in marine ecological monitoring. Which is, I mean, in a way, it's part of climate research. Marine monitoring is complex and requires adequately distributed spatial and temporal data. So, and we're now in the era of the digital twin, which is this idea of building virtual representation of things, and in particular, in this case of the ocean, in order to understand them better and protect them better. And these digital twins needs to be fed with a lot of data, most of which come from some fixed observation sites from all over the world, but the real challenge is to merge and interpolate the data coming from these fixed stations into a global mapping. And this is where robots comes in, especially to collect data where humans can't, which the ocean is more or less all inaccessible. So the idea using robot to link the fixed monitoring platforms, scatter around the seas, collecting data, and have sporadic observations to confirm or rebut scientific hypotheses. My very research is focusing on underwater legged robots, which is a bit unusual. Unlike the propeller-driven vehicle, this walks. And the fact that they're walking is bringing several advantages, and in particular in the field of ecological monitoring. The idea is that by walking on the sea, you can have a great positioning. You don't risk to accidentally hit things, which is one of the main problems with propeller-driven robots, and you can blend with the environment so much by not resuspending sediment and by having an acoustic footprint that is minimal. And this is very important for ecological monitoring because the noise and the footprint that you introduce is biasing your observation, which is in the end what you don't want to do. And so my project is about bringing these types of robots to the field of ecological monitoring, and this is about connecting these to fixed and mobile monitoring platform, and doing things like autonomous transects, counting fish with the minimal impact.
Thank you so much, Giacomo, to stay within the line. Thank you so much. And everyone can post questions to the Q&A, just a reminder. Thank you so much again. So next is Vivi.
Yeah, hi. So my name is Levi Kai. I also go by Vivi. I'm a final year PhD student at MIT and the Woods Hole Oceanographic Institution, where I'm advised by Yogi Girdhar and I collaborate with Daniela Roos. So scientists estimate nearly 80% of all animal biomass on Earth lives in the ocean, and yet only about almost 1 to 2/3 have yet to be described to science. Even of those species that are known, we have few in situ observations of them, causing large gaps in our knowledge. And so addressing these gaps are critical for understanding ocean ecosystems, especially those that play vital roles in the global carbon cycle. So the hypotheses underpinning much of my own research is that leveraging generalizable machine learning algorithms deployed directly on high-performance vision-guided autonomous robotic systems can vastly expand our capabilities to study marine animals, both across spatio-temporal scales, but also across species, including those we have little to no data about. So in the top left, we have shown that using semi-supervised learning algorithms combined with a custom hybrid tether type AUV can allow us to track arbitrary marine animals where we have no labeled data and without the use of tags. So here we show our system tracking a barracuda for nearly 300 meters, completely autonomously with no tags. In the top right, we developed highly parallelizable simulators for underwater robots that we can use to rapidly train agile 6-stop controllers for AUVs using reinforcement learning in a couple minutes. This allows us to deploy these vehicles in a wider range of environments and support a larger set of sensor payloads without copious amounts of tuning. And finally, in the bottom, my research explores how to measure potentially negative animal-robot interactions, since this may bias the data our vehicles collect about the animals they are studying. And in response, I'm also working with some collaborators to design new generations of vehicles and vehicle behaviors that are either quieter, soft, more biomimetic, or act accordingly to the animal response in order to minimize the invasiveness of these observation platforms. Thank you so much.
Thank you so much, Vivi. And next we have Francesco.
Yeah, hello, my name is Francesco Sarno. I'm here representing Switzerland Innovation Park, Bilbien especially. Switzerland Innovation Park is an institution promoting cutting-edge research all around Switzerland. In particular, in my group, we are below the Switzerland Innovation Park Bilbien. In particular, belong to the Swiss Battery Technology Center, a group aiming to use AI and reinforcement learning to automate the disassembly of EV batteries. So why the disassembly of EV batteries is so important? Because over the last decade, the number of EV sold has skyrocketed. And with them, also the end-of-life batteries number has increased. So this is a problem because essentially, if not disposed correctly, the end-of-life batteries are a liability, and the materials inside the batteries are also finite and rare. So that's why we are going through this circular economy where we try to save as much as possible from these batteries and to go through really circular economy. But since this is so important, why don't anybody does this already? Because actually it's challenging. There is no actually public data around, so manufacturers don't share it. Especially these models are really difficult different to one another, and a single conveyor belt cannot handle them all. And it's really hard even to hard code these robotic skills. So that's why we managed to go to synthetic data generation to create digital twin and train computer vision model and also reinforcement learning policies in simulation. Just to do transfer learning to apply all the knowledge that we gather to the real world application. So you can see here on the top, we have some application of computer vision tasks like segmentation detection and so on to real world, and also the policies learning simulation that is correctly mirrored in the real world. Thank you, everyone.
Thank you so much, Francesco. Next, we have Jenna. Just a second. Yes.
Hi, everyone. My name is Jenna Klein. I'm a PhD candidate studying computer science here at Ohio State. And my research is focused on autonomous sensing systems for animal ecology powered by edge AI. As we heard a little bit about yesterday, new powerful AI models can automatically extract ecological insights from images and videos at unprecedented scale, including animal detection, automatic species classification, and even habitat reconstruction and analysis. However, a big challenge is that these cutting-edge models were designed and developed to be used in supercomputing centers. So deploying these models in the field at scale to support autonomous sensing systems that are actually capable of producing actionable insights in real time remains a significant challenge. So to meet this challenge, my research is focused on deploying autonomous drones powered by Edge AI in the field, both here in Ohio as well as with our partners in Kenya. My goal in these deployments is to study these autonomous systems' unique characteristics, including their workloads, such as their service level objectives, the autonomic model request arrival rates, as well as their unique hardware requirements. And with this data, we can apply Edge AI techniques to improve the system for future generations of employments, including intelligently allocating model partitions and distributed inference to meet their very strict SLOs and improve the system robustness so we can optimize the monitoring capabilities for animal ecology settings. So by applying Edge AI to these challenging systems and environments, we can bring these cutting-edge AI tools out of the lab and out of the supercomputing centers into the field to enable the next generation of autonomous ecosystem monitoring and provide critical data for evidence-based conservation. So as I approach graduation, I'm seeking postdoc positions as well as collaborations with folks here at the intersection of edge computing, autonomous systems, and ecology. Thank you very much.
Thank you so much, Jenna. Next, Joel.
Right, hello everyone. My name is Joel Benson from the University of Abuja, Nigeria. I'm an agricultural scientist. My research innovation is about upcycling PET plastic waste as beehives for sustainable honey production. Now the problem statement. Globally, PET plastic waste ends up in the environment, causing pollution and also climate risk. The use of wooden hives in beekeeping also contributes to deforestation and the loss of forage. And this affects the availability of feed resources for bees and also accelerates climate change. So our project aims to solve this problem by upcycling PET plastic waste into beehives using an automated fabrication system. We are going to test two PET beehive models: PET beehive with plastic top bars and PET beehive with wooden top bars. Then we would compare these PET beehives with the conventional hives that are used by local beekeepers in Nigeria and also in Africa in terms of some scientific parameters such as colony establishment and also the honey yield. We'll also go ahead to analyze the honey samples using advanced laboratory techniques for heavy metal contaminants, plastic contaminants, and also for the physicochemical properties of the honey. Our project emerged finalists at the inaugural African Youth in AI and Robotics competition, Tanzania 2024. We received an initial support from Elevate AI Innovation Hub, which we are very, very grateful for. However, we are looking for additional support, additional funding of about 5,000 euros to fully implement our research innovation. And we are confident that this project is going to contribute towards mitigation of climate change and not just adaptation. And I will want to conclude with the words of Dana Yoga, who is a senior scientist in applied physics. He was part of the session yesterday as a panelist. He said something very, very profound. He said that we must stop dumping plastic in the ocean because the idea of scooping plastic from the ocean is problematic. It is not sustainable. Thank you so much for this opportunity.
Thank you very much, Joel. Next, we are going for Kenny.
All right. Hello, everyone. My name is Kenechukwu Mbanisi. Hopefully my audio is coming through well. I'm an assistant professor of robotics at Olin College of Engineering. It's an undergraduate-only college in Massachusetts in the US. I'm excited to share a project that my students and I have been working on. It's on developing a climate-smart mechanical weeding system for small-scale, particularly organic farms. Our goal was to create a robotic alternative to chemical-based weeding, which is a conventional approach, but also one that minimizes soil disturbance. And you can imagine that supporting no-till practices on farms. and also encouraging biodiversity for polyculture farming, and designed to be accessible and affordable to smallholder farmers. And so we started with a user-centered approach, spending about a semester engaging with local farmers in our community, and that led to a collaboration with a nearby organic vegetable farm you can see in the video here. And the result was a Phoenix bot. It's a prototype robot that navigates autonomously using vision to follow crop rows, identifies weeds and distinguishes them from crops using deep learning-based image classification. And we designed a custom-built Delta manipulator arm that goes to pick and extract or remove weeds from the soil. So we ran some initial tests last summer, and we had some pretty encouraging results, but this project is very much ongoing. The project recently won the grand prize at the 2024 Farm Robotics Challenge. So it's something that my students are very excited about. I am very excited about as well. If you want to learn more about this work or related projects that we're exploring, please, you can check the website there. I think it might also go on the chat. So thank you very much for listening.
Thank you very much, Kenny. And finally, we have Georgios.
Hello, everyone, and thank you so much for having me over here. My name is Georgios. I'm a research associate at the University of Bristol, and today I'm going to talk to you about Proteus, which stands for Protecting the Earth with Autonomous Systems. This is a scientific collective that's based in Bristol with 14 active members. We are gathering primarily outside of our main research, trying to shape projects that they focus on environmental actions. And a very key element is the cross-collaborative research that we do with environmental scientists at the University of Bristol, where we try to understand the problems from their perspective when it comes to biodiversity monitoring or the urgency of climate change and how we need to address this. So we organize collaborative workshops and different projects such as the ones that I'm going to talk to you about on the right. And at the same time, we're building a network of different individuals and hoping to launch some startups based on the research that we're doing as well. On the left, you can see some of the workshops that we have done on ICRA and locally at the University of Bristol. And overall, we try to, well, actually, we've joined the Climate Robotics Network a couple of years ago, collaborating with many of the scientists over here, which is also great seeing this effort expanding with the second summit. And some of the projects that I want to highlight on the right as well, which might also be interesting to some of you, is the Polybots project, which is trying to enhance, let's say, the habitats of pollinators using UAVs. And other projects that we're currently working on involve biosensing through different distributed networks of sensors. And we're also trying to build an educational biodiversity app for students to try and enhance, let's say, their understanding on biodiversity and the importance of protecting it. And last but not least is the sustainability analysis tool that we've developed, which is now used by all of our master students to try and shape projects that they are more environmentally friendly. So I think that's all for me. Please stay in touch and do send an email if you would like to learn more, and scan the QR codes, take a look into our website and get informed about our actions further. Thank you very much.
Thank you very much, Georgios, and thanks a lot for all the speakers. We encourage all the speakers to post additional links to the chat and the way that community can connect with you. And also we encourage audience to post questions to Q&A where our panelists can answer the questions over there. And we encourage all sorts of interaction in any of these mediums here. Thank you so much again, everyone.